In this lecture, I will be talking about managing economies of scale in a supply chain cycle inventory. One of the critical decisions that we make in any supply chain is about inventory. In the previous lectures, you learned how inventory affecting the entire supply chain. So in this chapter, we will cover role of cycle inventory in any supply chain and also talk a little bit about deciding the optimum lot size when we are ordering inventory based on the demand and some other criteria. So let's start with some definitions. What is cycle inventory? It is the average inventory we keep in a supply chain. So usually we purchase inventory in batch or in a lot. So the reason is that because we want to take advantage of economies of scale. So let's say that you have sports shoes retail store. So it is usually better to order inventory in large quantities. Instead of ordering one pair of shoes at a time, you order in larger quantities and definitely get a better price. So the same thing happens in many businesses. They keep inventory, they order in large sizes so that they can benefit from lower cost and some other advantages and benefits. So that's the reason we're talking about cycle inventory in this lecture. So what happens is usually we order in lot size, in a specific lot size. So lot size, we're going to show it with Q in this lecture, and later we will talk about the optimum quantity that we should order based on different factors. And also, obviously, we have a demand for the products we are selling in the supply chain, and we're going to show it with D. And so why we are keeping inventory? Because usually we order larger amounts compared to the daily demand. So usually in larger businesses such as Amazon, Walmart, Target, and others, they do order in large quantities, and therefore that's why they do have large distribution centers, large warehouses to keep this inventory, which is larger than demand rate, daily demand rate, and therefore we have built up inventory in these systems. Um, Actually calculating cycle inventory in this case, in the most simplified version, is just dividing Q, the lot size quantity that we order, by 2. And I will show you why this is the case. So let's take a look at example here. Let's say that there is this retail store selling jeans, and they usually order 1,000 units at a time. And they have daily demand rate of 100 units. So basically, if we divide 1,000 by 100, it takes 10 days to sell out the amount that they order each time. So basically, they do keep some inventory along the way in their business. But what is that inventory? So let's take a look at this graph. So basically, the y-axis shows the quantity, Q, or the order quantity, as well as the amount of inventory basically that we are keeping in the system. And x-axis shows the time. So you see that at the beginning of the time, let's say that we are starting from today, ordering some stuff, and then we're gonna sell them, right? So we order in Q, which is the lot size or order quantity. And then eventually, over time, people gonna come in and purchase the products, and then we will sell them out. So at some point in time, we assume that we get into zero. By the way, this is a simplified version, assuming that demand rate is constant, meaning that it's not fluctuating over time. Maybe this is for something that we assume demand stays steady. And then again, after inventory goes into zero, then we place an order, assuming that the order will come in immediately. Will not take some time. Obviously, this is a simplified version. And then again, we will sell products until we get to zero, and then we get a new batch and sell them, get to zero, and so on. In our example here, basically, this inventory profile shows that average inventory is 500 units. How we calculate average inventory by dividing the lot size that we order quantity by 2. And why is that? Actually, it's very simple. So what happens is that at some point in our system, we have Q, amount of inventory in our system. At some point in a time, we have zero. So basically what we do, we sum them up and divide by 2. Q plus 0 divided by 2 is the cycle inventory, the average inventory we keep in our system, and where this formula came from. Again, in practical situations, we know that there are some fluctuations. We know that demand rate is not constant. It takes some time to get the replenishment order. And also, usually we keep some safety inventory. So we don't really go into zero and then place the order. So in upcoming lectures, we will talk about more complex systems, and safety inventory, and other things. So for starting on inventory optimization, I have this simplified version. Hopefully later we're going to talk about it. And if you're interested in inventory specifically, inventory optimization, it is actually a field. And many researchers are working on very complex problems of inventory, specifically in tech companies such as Amazon, Walmart, and others. So, and developing new mathematical models using techniques in machine learning, AI, and making things faster and better. But if you're interested, I'm sure that you can find research papers out there. But in this lecture, we're gonna start with a simplified version and move our way toward a little bit more complex stuff. So let's move on to some other calculations we have to make when we are talking about inventory. So we know about cycle inventory, how many units of products we are keeping in average in our system, and why it is important because it has some cost. We are holding inventory. There is some associated cost with them. We're going to talk about the cost later. But also, it is important to understand how long will it take to let go of this inventory, and that will give us signals. When should we place the next order, the next order, the next order? Basically, that is the average flow time that we need to calculate. In order to calculate our average flow time, we need average inventory divided by average flow rate, which is the demand rate. So Q divided by 2D, if we make it Q divided by 2 divided by D, it is thus become Q divided by 2D. And then basically it's very simple in our example, 1000 units of Q divided by 2 multiplied by 100, which was the demand rate. And then it takes 5 days in average to, it takes 5 days in average for any unit of inventory to stay in the supply chain. So again, when we talked about 10 days, it was the entire time from the placing the order until we get into zero. But 5 day is the average amount, basically, any unit of inventory spends in the system. And again, this average flow time is being used critically in different supply chains. So some supply chains are more on the lean side, meaning that they don't really produce extra and they do not produce like in large amounts and keeping large inventories and spending some money sitting in warehouses. Rather than, instead of doing that, actually they do lean manufacturing, meaning that they do manufacture they decide about the quantity of manufacturing very close to the demand rate in order to eliminate wasted time, wasted products, not being able to sell products on time, and so on and so forth. For example, Toyota was the pioneer in developing lean manufacturing systems. Again, it is very interesting story. Um, that Toyota started realizing that they can actually reduce the amount of manufacturing, reduce the amount of inventory, and save a lot of time, energy, money uh, on the entire system. Uh, Improving the quality of the work, improving the waste, and all that. So again, some companies decided to lower their inventory level. Some companies still do keep a lot of inventory, specifically in global supply chain. So when it is about shipping products internationally, which takes a lot of time, and there might be some disruptions such as COVID and these geopolitical problems. It takes some time for products to get to their destination. So again, this kind of this decision about inventory can directly affect the entire supply chain. I talked about cost a little bit, but it is important to understand that obviously, if we want to reduce the amount of inventory, we are saving some costs, but also there are some other costs. If we are increasing the amount of inventory keeping, then we have to spend some money on holding costs. So let's talk about these three categories of costs, which are main cost in any inventory decisions. First of all, material costs. So the average price that we are paying per unit purchase. So let's say that you're paying for a pair of sneakers. Obviously, there is a price for it, and you're paying for it. What happens is that usually when you purchase in large quantities, you get some sort of discount for the volume. So if you are running a sneaker sports shoe store and you are only purchasing your inventory exactly based on demand, trying to be lean, then you might be having increased material cost in this case because you cannot use the discounts or you cannot achieve economies of scale when shipping things. So shipping one unit of product is usually more costly compared to shipping the entire truck, one truck for the entire order. So you should be considering material cost when you're placing order, when you're keeping inventory. Another cost in the system will be fixed ordering cost. So any cost that incurs uh, each time when you're placing an order. So you need an employee which is dedicated basically to the job. They review the reports and then they go to the system, place the order. So that's the buyer time. Transportation setup. So that person is responsible to figure out if they need a van, entire truck, if they do have a truck to be allocated to this order, or if the third party is providing the shipment, so all that coordination and basically any administration paperwork that needs to be done for placing an order. And usually it is actually fixed. Um, doesn't matter how many times you're placing that, you have to go through the same process over and over again. And then the holding cost. Obviously, in order to keep any unit of inventory for any period of time, you have to pay money. So if you own the warehouse, that is maintenance of the inventory, managing the inventory inside your warehouse. If you don't have the warehouse, then working with a third party, again, they will charge you for the space, for the work, for the energy, and all related cost of keeping inventory. And also, there are other costs involved in holding inventory. You are keeping capital unused, sitting in a warehouse. It is possible for some products that if you don't sell them on time, then you're losing your money. For example, grocery or high-tech products, smartphones. If you cannot sell before the next version is coming, then you have to sell it in very low price. And many other kind of costs that might be associated by, damages inside the warehouse and so on and so forth. So the goal of cycle inventory is to help actually decide about the best amount to order because if we order less, we lose some money, but holding cost is low. But if we order more, holding cost be higher. But again, we will be able to use the economies of scale in ordering. So there is this trade-off, and we are in this lecture are trying to figure out how we can minimize total cost, which is the summation of all these three costs in taking and ordering and keeping inventory. So why we want to balance cycle inventory? Again, because we want to reduce financial risk. Obviously, if there is demand volatility, demand fluctuates and changes all the time, we have to keep some inventory, safety inventory specifically, and make sure that we have enough, for demand that goes up and so on and so forth. Um, we want to cut some holding costs on the other hand. So again, keeping a lot of inventory, then it forces us to pay a lot of money for holding that inventory. So we want to lower the inventory. So we want to find this balance. And obviously, we want to achieve economies of scale when we are placing order for the inventory and use the benefits of ordering in larger sizes, specifically in global supply chains where it's going to take a lot of time to get products to the retail store. For example, many products are being manufactured in Asia these days, and they are being shipped to United States, and it takes time to do that. So let me check what you learned so far in this lecture. So please pause the video, review the questions, think about the answers, and you will find the answers in the next slide. The first question, if a retailer orders in lots of 600 units and if the daily demand is 50 units, what will be the cycle inventory? So we talked about the formulation of calculating cycle inventory and also how many days does a lot last. So I'm not talking about average flow time. I'm talking about how long that 600 units will last in the system, not the average. Question two, name the three cost components influencing lot sizing decision and what happens. So which one increases as lot size grows and which one decreases? We talked about economies of scale and also other related costs. Think about them. And then last question, how does cycle inventory level affect overall supply chain performance? Think about this. What happens if we order in larger quantities, order in less quantity, smaller quantities, and then what happens to the supply chain? the entire supply chain, other component of the supply chain, such as manufacturers to distributors to transportation agencies, what happens to them if we do that? If we decide to keep low inventory, if we decide to keep large inventories, what happens to them? And also think about the benefits and drawbacks of holding higher cycle inventory. How would you decide if for your business it is better to keep high level of inventory or low level of inventory? How would you decide about that? And then in the next lecture, we will dive deeper into uh, finding the optimum lot size that we should order for the supply chain.